So this graph is linear. Does this graph cross the x or y axis?
Yes.
Because that's what intercepts are.
Yes.
Yes.
So the x-intercept, where does it cross the x-axis?
The x-intercept, 0.
Yeah, so you list it as 0, 0. Does it cross the y-axis?
Yes.
Yes.
Same spot, right?
Yes.
Same spot, how?
They both cross at 0, 0.
Time and y was calories, and these are your intercepts. What does that mean? So when the intercept are 0, no calories burned. Because he just started. Basically, we have a graph about the internet use yesterday. So this graph looks like this. So we have months on the x-axis, yes responses on the y. The title is Did You Use the Internet Technology? So the question says, estimate and interpret where the function is positive. So if you are someone who needs to do this, extend your graph because the graph keeps going that direction. And the graph could go that direction, but it probably won't because it's months. And you have negative numbers on this side, right?
Right.
So you can't have negative months, can you?
No.
No.
We're just going to erase that part.
That's time travel, isn't it?
But it could keep going this direction. Because it only goes months since January. Well, they could do 90 months since January, 100 months. So this number could keep going positive. And then the graph could keep growing that way.
So it just expands.
Yeah. So where is it positive?
60.
Or, more simple than that, positive above the x-axis.
Oh, I thought you were going to say.
You mean you could say where x is greater than 0.
Why can't
Could
I
that-
say 6? About 60.
Increasing?
Yes.
Make sure you, so yeah, because increasing, which directions do we read?
Left, right.
Yeah, increasing, you read the graph left to right. And if you read it from left to right, well, here's where it starts. It is increasing, going that way. Is it ever decreasing yet? Not yet, right? Not that we can see. So is there any decrease?
No.
No. Is there a highest point or a lowest point that you can see?
No.
No. So,
Highs and the lows.
no extrema.
You can't really tell.
So let's just say no.
What it is.
So if they kept doing this study, what would the end behavior be?
Just keep going.
What would keep going?
Donuts.
So the months would keep going, so they would be positive. What would happen to the yes responses, you think?
They go negative.
I missed it.
Are they ever going to go negative, you
Yeah.
think? So this here in red is the end behavior. That describes the end behavior. Describe and interpret any symmetry. Let's just say I could fold it right here.
So what would you put?
So you could say yes, there is symmetry, or yes for symmetry. And you could say you could split it in half, where x equals 5. That blue line is x equals 5. And so that means that this side is going to be equal to that side. An education graph of education spending. So first question, identify the function graphed as linear or nonlinear.
Linear.
Is it in a straight line?
Wait, no, not linear.
Non-linear.
So nonlinear.
Draw the graph.
You don't have to. Then estimate and interpret the intercepts of the graph. So this one's going to be kind of hard. So I'm going to come back to intercepts for a minute. But does this graph have any symmetry?
No.
No. There's no way I could fold this graph and it would be equal on both sides. Is this going to be a positive?
Mm-hmm.
Because it's above the x-axis, right? So positive graph. If you read it from left to right, is it increasing or decreasing?
Increasing.
So you don't have to write decreasing because it's not doing any decreasing. Because you're not reading it from right to left, you're going left to right. You don't have to say negative because it's not below the x-axis. Is there any relative extrema? Is there any high points or low points that you
Yes.
can?
Oh, yes.
But can you see them yet?
No, not really.
Not really, because they really just keep.
You can't see the one to 0. 'Cause
Yeah,
it-
I mean, you
it
could
keep
say-
going straight.
But the low is where it started.
So that's not.
Yeah.
That's the
So
low
there's
point.
really no extrema. But what do you think is going to happen later on in this graph for the end behavior?
It's gonna keep going.
So the yearly spending is going to keep going up.
Yeah.
So X is going to keep increasing, or the Y is going to keep increasing as well.
Mm-hmm.
Now I'm going to zoom in on a graph and show you the inner. Really, this graph is not really going to, it might cross right at 0.
Might not.
This is kind of an exponential graph.
What's that?
What we're going to learn later on, but we don't have to worry about that now. So, because this graph really isn't going to cross the x-axis. Because look at what it's called. Are you always going to have a year? Years always go by, right?
Mm-hmm.
So can I ever have like year 0?
Maybe the first start of the world.
No, not really. Wasn't that like AD or BC
No,
or
0.
BD or
It
something?
was 0.
So you don't really have, but you do have a y-intercept. Where do you think in 1949, where does it look like it crossed the y-axis?
1,000.
Like if this is 100, where do you think it crossed? Like how much do you think things cost in 1949?
Probably
0
Or
books.
like,
I would go a small number.
3.
$3?
Price.
Well, we'll do 5. We'll just say they count by 5s.
5, 10.
Yeah.
We should do $10.
So that could be your y-intercept. Because I doubt in 1949 things were free, were they?
no,
I stole it.
You think they were free?
they were not free.
And look what it's called. Spending.
Well, it was like.
So you think they had to pay for things back then?
Yep.
So your y-intercept could be something like 0.5.